Assalamualaikum warahmatullahi wabarakatuh. Before discussing the material given, introduce me from Group 9, which consists of myself, Siti Nurbia, and my friend Aulia Diar Hasja. After saying the title of the material, many may ask, what is linkage? There is more than one gene in a particular chromosome. The genes that are on the same chromosome are called linkage genes, while the phenomenon itself is called linkage. Sex linkage is a condition where there are many genes in one chromosome. This usually refers to the body chromosomes or autosomes. As a result, when the chromosomes separate from their homologous chromosome, the linkage genes are always together. X chromosome linkage genes are genes that are found on the X chromosome. Females have the XX sex chromosome arrangement. There is a pair of sex chromosomes that are truly homologous. This renders dominance and recessive loss for traits determined by X chromosome linkage genes in females. Y chromosome linkage genes are perfect sex linkage genes. This chromosome linkage gene is called Hollandric, meaning that the inherited trait can only be found in males. Organisms that have XY chromosome. Most of the Y chromosome do not have homologous on the X chromosome and are also very rare on the Y chromosome. Types of linkage. The first, based of crossing over. Linkage may be classified into complete and incomplete or partial linkage. Complete linkage. It is known in case of males of Drosophila and females of silkworms, where there is complete absence of recombinant types due to absence of crossing over. Incomplete or partial linkage. If some frequency of crossing over also occurs between the linkage genes, it is known as incomplete or partial linkage. Incomplete linkage has been observed in maize, pea, Drosophila female, and several other organisms. The second, based on gene involvement, depending on whether all dominant or some dominant and some recessive alleles are linked together. Linkage can be categorized into coupling phase and repulsion phase. Coupling phase. Dominant alleles present on the same chromosome and recessive alleles present on some chromosome. Repulsion phase. Dominant alleles of some genes are linked with recessive alleles of others. The third, based on chromosome involvement. Based on the location of genes on the chromosome, linkage is categorized into autosomal linkage. It refers to linkage of those genes which are located in autosomes other than sex chromosomes. Allosomal linkage or sex linkage. It refers to linkage of genes which are located in sex chromosomes, i.e. either X or Y, generally X. Gender linkage. Sex association describe a specific pattern of sex inheritance and presentation when gene mutation alleles are present on sex chromosome allosomes rather than non-sex chromosome autosomes. In humans, it is called X-linked, predominantly X-linked, and Y-linked recessive. The inheritance and presentation of the three differ depending on the sex of the parents and children. This makes them distinctively different from autosomal dominance and recessivity. In X-linked recessive inheritance, boys born to unaffected carer mothers and fathers have a 15% chance of being affected, while girls have a 15% chance of becoming carriers, but a minority of carriers may show murder or even fullness, a condition resulting from a phenomenon known as exquisite inactivation, in which the normal process of deactivation whole of the female body X chromosome is preferably targeting the X chromosome of a particular parent, in this case the father. If the father is affected, the son will not be affected because he does not inherit the father's X chromosome, but the doctor will always be the carrier and can sometimes present with the symptoms due to the inactivation of the X gene mentioned above. In X-linked dominant inheritance, assume a doctor born to an affected mother and an affected father but have a 15% chance of being affected, although some X-linked dominant conditions are embryonic later for the son, making the affair to occur only in women. If the father is affected, the son will always be unaffected, but the doctor will always be affected. The Y-related condition will only be passed from father to son and will always affect every generation. From the picture can be seen A. The affected father has one X-linked dominant allele. The mother is homozygous for the recessive allele. Only doctors all will be affected. B. Heterozygous affected mother with one copy of the X-linked dominant allele. Girls and boys will have a 15% chance of being affected. C. The heterozygous mother is called a carrier because she has one copy of the recessive allele. Boys will have a 15% chance of being affected. 15% unaffected girls will become carriers like their mother. I'm sorry if there is a wrong word or pronunciation. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.